Thanks.
Hey guys, Austin Adamson. I'm. Ooh.
You're off.
Oh.
Try it again.
How about now? Testing. I can also. Okay, cool. I'm just gonna hold it in my hand instead. Yeah, I'd hope so. There we go. Hi guys, Austin Adamson. I'm over at Athene right now. It was one of the more recent projects for me. And one of the things I noticed when I went over there, the normal just getting started up on a team, and I need to get familiar with a lot of code base really fast. And so one of the things that helped me with that was I instead of going through each repo individually, I loaded them all in to my command folder, and then I had them all next to each other. And so whenever I had a question of what was connecting to what, I could start having context between each of them. And so, for example, if I was looking for a where a certain function called out to, we have an intake process and an outtake process, how those connect into each other wasn't very obvious at first, and so it was a little bit jumbled. And so having it be able to like not go first over to the intake project and go like, hey, how do you go out to there, and then go over and how it's receiving it, it can have context of all of those and go through them, which was really nice. One of the nice things about that as well is across the entire project itself, rather than the individual repos, you can have your Claude MD for how you want it to facilitate between them. And so that makes it so that each project has a little bit of its own style, have a little bit different rules of how you want to go about it, and you don't want to waste time in there. So you can have it where generic things of rules you want to follow as a holistic at this company for this project, and that'll live in there. And then each individual one, you can have it bubble down and be specific towards that. I've had it to where then as the organization level, I'm starting to mess around with that. So then not just that project itself, we've been spreading out a little bit more to other teams as well. So moving that even higher to where then you have different projects, and then it's an organization level one, which is kind of fun. The nice part about that too is you can, with those, you can have it develop an architecture diagram between them when I was getting there. And so instead of, because when the architecture diagram that they gave us wasn't even close to accurate, it was their idea at first. And that's a very common thing for any project I've ever been on, is they'll give me documentation. I'm like, are you sure? I don't think that's how that works. And so I was able to get it, and it would update each time whenever I would have them all pull from main. It would update that diagram, so then stuff that I have not been in a conversation with or working in those repos for like a month or two, then I'd be able to see the kind of changes of structurally, just on a level where it would still affect me in the specific scenario that I'm in, and then I can deep dive from there. And that was really nice to be able to have those kind of conversations with people that those higher level conversations, because a lot of the times teams would still get feudalistic and be like, this is my project. I only really need to know about my specific repo right here, because that's one I want to know about. But being able to have them share out with them these diagrams, they're living documents. It was night and day difference on the way they talk to each other, because they were able to see the kind of effect they were having on other teams. That's pretty much all I had. Do you guys have any questions? Yeah.
Yeah, I'm curious if you, like, I'm assuming that when you're building out the context between repos or doing analysis, you're somewhat relying on Claude's memory.
Yep.
But have you experimented at all with doing some of that analysis and kind of keeping different documentation up to date, right? So if you
Yeah.
have a new come on, then everybody's going to spend the same amount of money in tokens processing that same amount of memory.
So
All the analysis for all those repos. So I'm just curious.
yeah, I'm glad you brought that up, because the command repo is a repo in itself. So when you're having that, you have that what that project's agreed rules are. So as a project, usually you come together and you're like, from the small stuff of how you guys decide to do tabs versus spaces or anything like that, to actual I need to make sure that this percentage of code coverage or whatever you want as a team, that charter that you guys decided to that evolves over time, it's not going to be correct as the beginning too. And so that repo gets updated with your own. And you can still have your own personal one that has a git ignore kind of one that's your own MD file of your specific ones. But that team one that everybody has to follow and that you guys update when you have a conversation to update it would get updated as well. And that's what holds those architecture diagrams. That's what I was meaning with the people that normally wouldn't have those to see. They'd only see it in their scope. They have access to it if I point it to them because they're like, well, I don't know how that works. I'm like, if you pull it, it's right here. And so then each one of them has that. And it's the same for everybody rather than everybody having their own individual like lens. And so you get that holistic view of where we are a project together rather than I'm my team and this is what I'm only responsible for. It really develops that sense of we're building this together.
Sure.
Yeah.
So these are like in a C4 diagram sense, these are kind of the upper level diagrams.
Yeah.
The more broad ones.
Yeah.
Where are you finding was like good storage for places where it's like, oh, this isn't owned in this repo. This is owned across 8 repos.
That's also in there because like this is everyone that's in the project. You're talking about, so when I have it on the project, it's a diagram across the entire project. So each repo builds into that specific diagram. Are you talking about when it's outside of the project but it's still kind of connected to it?
I guess, yeah. That would apply, yes.
Yeah. So let's say I have my project. Let's call it Project A here, and then across the org there's one that we do talk to and connect to, but it's Project B over there. It still could live in the same place, but it's not the one that's getting updated each time. And so I wouldn't update each time because it's just context that it really doesn't need. So then anytime you're doing something that's connecting to that, so you just pull that on in again. And so it will update that based on main. So every single time I do normally a /clear to update the context, then the only context it'll bring in is the those architecture level stuff, the diagram of what it understands the entire project to be. But then a reset will pull all of the mains down and then just check if there's anything different structurally. Not any syntax things here or there, but actual structural change to the whole design of what we're trying to do. Does that make sense? And then so that one you just pull in separately. I keep that one out of the context of the constant resets because you don't need it. It's just one of those where you'll pull it when you do need it. Yeah.
Is Claude relying on like agents MD files in each of these repos? Like, do you have that sort of consistency across, or is it really just going out there and figuring it out for itself?
You don't have to have it in individual ones. I started to in some of the larger repos because they had different kinds of decisions inside of those. So then when I was working in a project, I could have the rules of, okay, well, it's already following the rules, the org rules per se, and then I have my project rules. And so it's a case-by-case basis. I haven't seen a need for it to specifically be in every single one, but that overarching one, it does just sprawl out and then pull back, and it's really good using like ultra code to where it makes an agent for each one of them and then pulls it back and then sees the picture, puts them together of just basically threads. Cool. Yeah, one more question, then we're done.
Do you use any other tools, or like Treesit or anything like that, or just let it use batch tools?
I just let it go. So I'm decently fresh to it, so I'm definitely down to check some cool stuff out. But it was just a problem where they wanted me to get online as fast as possible, and it was honestly surprisingly better than I thought it was going to be, because with sending out to try to figure out like 12 to 16 different repos, I didn't have high hopes on it being able to get a good diagram, but at least helped me narrow down my search. So when I had a story, I could based off of this architecture diagram, where is this bug that they gave me potentially? And it'd go, one of these 3 repos are the only way that could happen. And so I was able to, instead of going, I'm lost, I need to ask another developer that has more experience, I could be more self-reliant, more Claude reliant on going, hey, where am I going here? And so I could narrow down that search so that a new dev at a company would take them potentially a week if they were sent like out to dry. Now I can at least narrow it down to where it's going to take me just a day or 2. Thank you. Oh, do I have one?
Hold it or just
Tap it once.
Okay.
It should be good now.
Test, test, test. That's going through? Okay. Alrighty. So while we're getting the screen share figured out, I'll introduce myself. So I'm Kyle Wagner. I'm a software consultant here at Source Allies, and I'll be talking about time series databases.
Hey Kyle, we're getting a little bit of noise here. Could you speak up a little?
Yeah, sure. Is this coming through? Like, it's hard for me to tell.
Switch mics. I think that was
Test, test. Test. Try to go with the lapel, otherwise I'll just go like this. This will be better. Do you know what's up with the share?
it should be sharing. Hold on, I get to kind of
Okay.
This one, not this one.
You need to walk away from it.
This one here.
Oh, okay.
Sorry if you wanted that other screen. If you want it.
No.
Okay.
Nope, I just didn't know.
Pop up then.
Good to know.
Switch windows now, so you do the second window for you. Sorry. It's just
Right.
on the second window, so just
Drag it over.
you can drag it over or just mirror.
Do I have to do mirror in here?
Yeah, do displays. There, displays. Yep, and then you pick on this guy, HD, extend, just do mirror display. Yep.
All right. Well, at least I had the shortcut down for how to do full screen. I practiced that part. So, time series databases. Developers' introduction to metrics, labels, queries, and cardinality. So I am currently on a project, I have been for about a year, where our job was to help a LAN team, so a local area network of a large company, improve their observability of the network across many sites around the globe. They have manufacturing, warehouses, offices around the world, and they're rolling out a different vendor of infrastructure, going from one type of networking equipment to another, one brand to another. And part of that rollout includes wanting to better monitor, observe the new sites as they're being transitioned, and then answering the question, is the site healthy? Ideally being more proactive. So that's been our responsibility, is to try to figure that out. And they have about 10% of the sites maybe currently rolled out, and over the next 3 to 5 years, they all will be. So I'm sure you've seen metric data or time series data. You may not have thought of it that way, but like in the example I gave, which is comparable to the project that I'm currently working on, if we had 3 sites, going left to right, the independent variable being time in almost all
cases for this type of data. That's why it's called a time series database. And then if we could evaluate health, we could see if that was going up or down for a given site, and then we could have other charts that would dig into why. So we visualize with a tool called Grafana, which you've maybe seen, allows you to do all kinds of visualizations, and all of our Grafana dashboards are backed by a Victoria Metrics data store, which is a time series database for metric data. We'll get into more of what that means. I will say if we could actually produce a good health metric for these sites this easily, that would make my project very easy. That turns out to be very hard to actually synthesize all of these different data sources down to an evaluation of health that actually means something. So where does time series databases fit into kind of the landscape? So there's this book that you've maybe heard of called Designing Data Intensive Applications, which I didn't read the whole thing, but it's one of those books that people point to as like for systems design. This is one of the books that you should read. And it framed up applications and their design in a way that was kind of new to me, which was like going back to the data sources and how data is stored, how it's organized, the different kind of types that you have available. And it talks a lot about relational and document data stores. So relational data stores, of course, like everyone's worked with those, so MySQL, Postgre, etc. Usually used for mapping relationships between entities, so like an invoice, a product, a customer, how those interrelate. You don't have to put everything in a single table, but you're designing multiple tables that interact with each other. Of course, very broadly used. Also, I would say, and I think a lot of people would agree, they are overused, in part because it's the hammer you had in the past, and so it got used for all kinds of things. A document store would be like if you've heard of MongoDB or used it, or in AWS DynamoDB. There's an engine called DocumentDB, which is the open source kind of version of MongoDB. And that is flexible, so each item doesn't have to be structured the same way like it does in a relational data store. So that's one of the advantages. Also, it can be very cost efficient because often it's backed by like a serverless engine or a serverless infrastructure. And also, one thing that I think is kind of neat about it or nice is that it's sort of like JSON native. Like if you see items in a document data store, it just looks like JSON. And often that is just kind of like a nice side benefit. It's like you're just going to and from JSON, and it ends up working really well. So what we're going to be focusing on, though, is time series databases. And so, like we talked about, that's measurements over time, and it is efficient at doing append data. So as time goes by, you're just appending more data and working with data in terms of series. So how you're able to group data over time into ways that allows you to gain insights from it. And so basically how you can end up charting that well. So what we usually see from time series data is like line charts like this, but what it actually is streams of data or database points in time. So like in this top line, you can see like the actual points are called out, and the bottom two lines, the points are not called out. But if you took away the connecting lines between these, what you'd be left with is just a bunch of data points. And how those data points become a series in a line is what we'll talk about next. So in a time series database, you end up with data that looks something like this in reality. You have a bunch of timestamps and you have a bunch of values. Now you can see that these values are very different. One is over 1 million, several are under 100, one of them is under 1, and those can all just, sit next to each other. So you need something else to bring more meaning to these. And the pieces of what that something else are is primarily the labels. So for a given metric, in this case, device CPU usage %, that would be the metric name, and then the different like attributes of that metric, in this case would be a site name, a site ID, a device name, a device type, and a region. So it's a set of like key value pairs for each of those different entities. So what makes a series or a line in a chart instead of just a bunch of different data points that aren't connected is a name plus the labels. So there are different types of metric data, and metrics aren't the only type, category of data that can be stored in a time series database, but it's the one I've been working with most, and what I think is a very interesting part of time series databases. Like, for example, logs would be another time series based way to store data, but I think the metrics are more complex and more interesting in how they end up working. But anyway, the different types of metrics that you will see from like Prometheus documentation guidance are counters, gauges, histograms, and summaries. Summaries I haven't worked with at all. Histograms only a little. Counters and gauges, in my experience, are what you will encounter most often. So gauges in particular, so it includes values that can go up and down. So like CPU utilization, for example, or temperature of a device, things like that. Counters only go up. So like if you're tracking the number of API requests, like the total requests or the requests that resulted in error, if you define a metric as a counter, that will only go up. And then you have to operate on that with functions to derive insights from it, like using other functions like a rate to see over 5 minutes, over a half hour, what was the rate of increase. So when working with metric data, you query against it, but it's very different from querying SQL relational databases. So my previous project from the one I'm currently on was actually very heavily based on relational databases. It was like a data warehouse project, and I had to go much deeper into SQL than I had before, and that was a really interesting experience, learning about joins and primarily because that's one of the big ideas in relational databases. And then I had to try to kind of translate that and understand how time series databases and with metrics specifically is different. So if you just run a query on a given metric, that's kind of like just doing a select star on a table or something like that, or selecting a specific column in a table. You can do limiting, or you can do restrictions, like kind of like a where clause, by using this kind of syntax with putting it in braces and saying, for a given label, I want only this specific value of a label. So device type, in this case, access switch. Another device type might be an access point, or a collapsed core switch, or a different type of switch. And then to kind of bring this all together, what you'll see more commonly with queries is ways to both restrict and aggregate and use functions of one kind or another. In this case, we're using a count function to say how many devices have greater than 70 CPU %, and we want to group those by region. So like in SQL, you can use group by clauses to kind of collapse a bunch of records together. Similarly, we can do that here. In this case, we're using region. We could also use count by site name, but in this case, it's region. So relating this back quick, I'm not sure if I covered this as well as I intended to, but like this is the same metric here that we were just looking at, and this has a region in addition to a site name and a site ID, etc. So in this case, it would count, and you would get a chart like this, where you have Midwest, South, and West, assuming those regions were in your metrics, and it would run the count and aggregate those for the region. So this is the last concept I want to talk about, and this will come up if you work with time series databases metrics specifically in depth, which is cardinality. So the cost multiplier. Every unique combination of label values creates a separate time series. So this multiplication here demonstrates how that works. So like if we have 20 devices and there are 48 ports on each of them, if they were switches, and each of those ports we are tracking 4 different metrics on, then you'd end up with 3,840 series. Now, the actual numbers here don't really matter that much, but what is important is really like the operator between these. It's a multiplication. And so not only, in this case, we're saying devices, ports, and metrics, multiplying those, that will give you a series. But depending on the design of your labels that you are using for your metrics, those can also result in a multiplying factor. And so a database that has series or metrics that are designed with very high cardinality will have problems eventually, and that will impact like how much data you can really store in there and efficiently query, if you can or cannot efficiently query that data. So some good labels are labels that don't impact cardinality negatively. So like in this case, site name, site ID, region, device name, and device type. None of these are more specific than port, so they don't have a negative impact on cardinality at all. Now, what would impact cardinality negatively though? So one example would be like if this doesn't apply well to like a switch necessarily, though it could depending on what you're tracking for the metric at a port. But if you have like client level data, like a user email, something that's going to be different for every single client, that means that you're going to be multiplying your number of series by every single client. And this is an example that came up actually on my project where we were getting back an API response, doing some transformations on that and wanting to track that data as a metric. And there was a message, and the like short message was success, fail, something like that. There was a longer message that was a little more detailed, but in both cases, the range of values fell within a relatively small range. It was like, you know, the short message might be 3 or 4 values, the long message might be like a dozen. So in that case, you could include a message as a label on a metric and you would be okay. Jonathan's telling me to wrap up. We're almost done. But just imagine if the message that came back included a timestamp. Now every time you write a value to that message label, it's going to be a new series, and that's just going to blow up your cardinality. So something like that is something to watch out for. So this is just a brief summary of the mental model. While I'm wrapping up, you can just read through here quickly. I want to make sure we leave time and space for everyone else. But if you have any questions, feel free to flag me down you know, while we're all still here. So thank you, and we'll move on to the next.
Check. John, is it okay if I move this out here?
Yeah, but if you need help or whatever, you probably got it.
I'm so strong. Hey everybody. My name is Joel Miller. I'm a platform engineer at a nationwide retailer, but here speaking on behalf of myself. So what I'm going to be talking about today, I'm going to try to write and talk at the same time. Can you hear me? Talking about synthetic tests. And I am coming at this from an SRE perspective. So I was previously an SRE engineer, How many companies have an SRE team at their company? Couple? So SRE are site reliability engineers, and they are who keeps the system reliable. If your company doesn't have an SRE team, not all companies do. Usually they come after a major incident or there's something bad happens, but definitely practices as software engineers, as DevOps engineers that you can put into practice yourself. Google provides the SRE handbook for free online. It's definitely worth taking a look at. One of those things that we're doing within SRE is defining service level objectives. And so going off of Kyle's presentation with metrics, this is defining what is reliable. So if you get a ping in your support channel and they say, is your system healthy? Is your product healthy? How do you know? Because it feels good, because there aren't errors in the logs. And usually we're defining this by two things: errors and latency. I mainly focus on error or status codes. Latency, it really depends on how time sensitive your system is. If you're shooting for, say, a 6 millisecond response time and you're at 15 milliseconds, should we page you in the middle of the night? Probably not. But when we're defining SLOs, we're trying to say, how much of the time do we want to be returning a successful status code? And so when we think about successful status codes, a lot of the times we're going to be thinking about, 2XX, but we also want to account for things like 404s, users requesting something that isn't there. That's not our problem. That's not why we're getting up. But if we are looking at like 500 errors, we want to define what percentage of the time do we want to be sending back non-error response codes. A lot of folks shoot for the 4 nines. I can guarantee you, out of the box, you're probably not going to be close to that, and honestly, that's okay. I would say when you're looking at your data, you want to start in reality of what you're currently doing, and so that might be 96, 97%. But this allows you to know if somebody comes in and asks, is your system up and healthy? For an API, for instance, this is going to be that indicator. And that is based off of metrics like we're talking about, and then bubbling those up and then creating a number that we can look at and say, this is what we want to hit on like a 30-day rolling window. And the more that we think about our services as products and even our internal users as customers, it helps us define, like, are we doing the right thing? If we deploy and this number goes down, we're doing something wrong. If it stays stable or if it's going up, obviously heading in the right direction. And then our SLAs are our promise to customers. A lot of times we're dealing with these from like a provider level. We have SLAs with our cloud providers. We guarantee this uptime, or you can call finance. Internally, we don't have that same ability, but I would really think about if you're working on a platform or even a product, if you're facing customers, what are you promising that your system's going to do? What percentage of success are you looking for? And that's usually going to be broken up between these two. How fast is it? How accurate is it? But having those signals is a really good way to know that. But like we'll be talking about today, that's not always going to be the whole case. So my journey into synthetic tests was quite a bumpy one. And I'll talk about some of the things that I found worked well for synthetic tests, and some things that I found did not work well. So we can think about synthetic tests. They're really automated users. So as engineers, does anybody have like support channels? Are you hit up for support for things? So the idea here is, instead of letting our customer know, hey, your stuff's busted, and then you go, news to me, let me look at it, that is going to be a long time for the mean time to detection, and then also the mean time to recovery. So you're constantly chasing your tail of customer lets you know system's broken, you find out for the first time, now you're starting the process of going to figure out what's happening. So use cases where I feel this is really effective really depends on what are the most painful things that you're currently dealing with at your company, what are the most common questions that you're getting, and what are the things that are keeping you up at night. If they were to go down, what's going to have the biggest, broadest impact? So things that work well are like login. So we can create a synthetic test, deploy it as a cron job. It goes out there and 24/7 is testing login. Considerations that you'll have to make are how often do we want to run this? Do we want to run it? The initial thought is like, oh, I want to know, within 5 seconds. You really don't. You want to spread it out in a realistic amount of time. And you got to think about, too, with the synthetic traffic that you're creating, it is actual traffic. So if there's any sort of artifacts from that, things that you're not thinking about, there can be drawbacks there. Also, for every synthetic test that you're making, you're creating some level of maintenance for yourself. So even for something simple, can I log in? We want to know about that. If it goes down at 2 a.m. and our users log on at 8:30 and the whole company can't log in, it's maybe not at 2 a.m. we're getting up in the middle of the night, but we want to get a head start on that before, or maybe we are getting up in the middle of the night, or we're passing off to an offshore team, whatever it may be, but we're knowing about it well ahead of customers and we're able to do it. The best cases that I find for synthetic tests are like really actionable user business value things. This is not a replacement for integration testing. This is not a replacement for SLOs. But when we think about login, for instance, so say we have our API deployed here. This could be on-prem. And we're measuring SLOs on the API. If, for instance, we have users in many regions, we've got folks in US, can't spell, East 1, and US Central 1. And today they're doing construction on the road and they cut the fiber line to East 1. As far as our SLOs are concerned, we're doing great because the requests are never actually getting to us, but half of our user base is not able to log in. So when we're creating these synthetic tests, it's important that we deploy to where our customers are. We want to recreate their experience as much as possible, so we're alerted as soon as possible. So quick, bite-sized things, getting, say that we're fetching bucket details, or we're grabbing a file. That's something that we can rinse and repeat. There's not a ton of maintenance there, and we're able to replicate that, and we can run that 24/7. Companies will have the desire to start chaining a lot of different calls back to back. That's where I've found a lot of problems. The first synthetic test that I really worked on was between, I think there was like 24 different hops moving back and forth where you're grabbing one payload and passing to another. So for instance, if you work for tractor manufacturer and they have a website where you can select a tractor, upgrade it to all these different things, checkout process. Now we're working on fulfillment. where it's at the factory, shipping it to a customer, tracking all of that. Being able to manage all these different systems and teams is going to be really difficult and brittle. They're going to change their API. You're going to have to reach out to them, update that constantly, and it's not going to be fun. Same with thinking about if you're doing like CRUD operations, if you're creating resources and you're testing that. These things run all the time. Every 10 minutes is a lot, over 24 hours, over 365. And so if you find yourself having to write like tons of cleanup scripts, or if something goes wrong, it's having to recorrect itself, you're probably breaking off too much within one test. I would argue you could probably break them into chunks where it might be, create. We might have a test for fulfillment. Where we can have different customer processes broken out, but doing it all as one long end-to-end test is not effective. As far as getting started with where to start, I would say as engineers, you probably know where your pain points are or what your most common customer complaints are, especially from a platform level. We want to answer, is there something wrong with the platform, or is this user having a problem? Because a single user having a problem, not a huge deal. If every user has a problem, pretty big deal. And so when you're brought those different things, you can rely on your SLOs, your synthetic tests to tell you, okay, well, even though our user is able to log in, we can suss out with the SLOs, with the synthetic tests, that our system is healthy. There are, a bunch of different companies that will offer different packages of doing these type of things. I think that's mostly effective if you're a nationwide company and you want to know from each region, can your resource be reached? If you're in the Southwest, Southeast, Northeast, they will allow you to deploy to different places. I would argue, as software engineers, these are much better made by yourself, or rolling your own. As far as language goes, I would argue to use whatever language you're already writing. Don't reinvent the wheel for this. Make it easy. You want your weakest engineer to have confidence if they see a good use case for a synthetic test that they can write their own. I would say have it read some sort of configuration like YAML. Make it simple. Look at the status code. That's going to tell you what you need. Don't be examining the body and having like a full check, regex check, in case any little business logic changes that all of a sudden your test is going to fail. The more maintenance that you do on these, the less important they become. And that's where I've seen them fail, of doing one gigantic end-to-end, purchase product into fulfillment, into customer receiving product. It becomes more work to maintain the synthetic test than the actual value it's providing. So it's just a tool that you can use, but when used sparingly and being diligent about the different use cases that we're doing, and let your support requests drive these things, whether it's a customer making a mistake or the platform's down, it allows you to have much better insight and recover a lot faster than waiting on the customers themselves. Any questions? Austin.
I have a question on, so you have the test basically where you place it on east, let's say east one and then west one,
Mm-hmm.
and then east one is the one that's failing. When you set the automated user over there, but do you have an automatic failover when it finds something like that? Because I don't want to wake up at 2 a.m. If it can try to resolve it itself and then just point those and have them run off of the other server, do you start to like forward think and because that helps your mean time to recovery
Yeah.
by having those adjustments? Not all tests are going to be like that, but is that something that like you guys
true. No, that's much smarter. I would say no, but and try not to get into too much AI stuff, but as agents and those things become better, that now becomes a tool for fixing. I would say the thing that I focus on most is not waking you up at 2 a.m. unless we really have to. So build in retries, have it fail multiple times before it's kicking off, because you'd be surprised what happens at 2 in the morning where you have blips, weird blips that, if somebody's running like a performance test, you don't want one failed thing to all of a sudden, because then people become desensitized and they don't answer the alerts.
Yeah. Thank you.
Yep. Happy to answer any other questions later.
I think it's use that one. Thank you. Switch back to yeah, sweet, good. Thanks, man. Oh crap. Sorry, I need to clean this up. Cool. Hello, hello. I just turned it. Hello, hello, hello. Can you hear me? All right. All right, thanks. Hi, everyone. My name is Mason Spree. I also work at Athene, so I haven't met you before, so good to meet you. I've been at Athene since I was an intern, and then graduated, started full time, so about 5 years now. So still relatively new. My title is the human element in an AI world, which is pretty dramatic, so you know that Claude wrote it. But really, when Jonathan messaged me asking me what I wanted to talk about, or if I wanted to talk about anything, I think the thing that's been the most on my mind recently is being a software engineer or software developer in today's world, especially like early career. So I kind of have the visual up just for you to look at, but this is really just my musings. Being a early career professional and using AI pretty heavily. So I wanna hop on the time machine and go back about a long time ago, about like 3 years ago, and just kind of follow where we came from. So like I said, I'm still pretty new, but I was around before writing code with AI. I was in the weeds, writing lines of code, smashing my head into a wall, trying to debug something. I thought what you were talking about was really fascinating about reading code bases, because, like you said, it would have taken months, and if you were new to a team, maybe even years, if it was really complex. And now that's done in a matter of days. But I mean, that's the way it was, and that doesn't take into account all of the other things that we as software engineers do as well, which is important. I'll talk about here in a second. So then I think it was like 2 years ago, there was a big AI boom, and everyone kind of started freaking out about AI tools, and I think, Athene, and all of these are from my perspective at Athene, but I think it's pretty much true for a lot of companies, or most of them, started to adopt these tools. And Athene, it's a part of our goals for everyone to use the tools, and I don't foresee that going away. But adoption is kind of on the rise. I would say pretty much at Athene, everyone's using Claude Code if you're a developer, even non-developers or citizen developers, as people, the new phrase has been coined. But there's just a slide about, I think trust is a really big thing with Claude and AI. And I think over time, that trust is gonna grow. So just throwing that in there. So that brings us to today. So what's really different? And when I think about it, and when I distill and I worry about losing my job,
the biggest difference is now we have ultra effective productive tools that write code. I mean, I don't know if I've written code by hand in months, and you know, I'm really conflicted about that sometimes. Writing code was never my favorite part of the job, but I think ultimately that feels where we're trending. I know there's that I think there's a quote on the next screen. There's that very popular quote that says, AI will not take your job, but someone who is using AI will take your job, that kind of thing. So it kind of feels inevitable. And that just kind of leads me down a path to say and ask myself, you know, so what makes developers useful? Why am I going to have a job in 10 years? And I think it really comes down to, there's a lot of good reasons here, but I think ultimately, in my opinion, from what I've experienced, it comes down to context. And I know context is kind of the big word when you talk about Claude or the other tools. I haven't dabbled as much in those tools, but context management is how you create something decent out of AI tools. You know, there's the saying, you know, junk in is junk out. Like all that is true, and context management is so important for the tools and getting an appropriate result. But that context is never going to get created by AI. Sorry, and so. Well, I think that like fundamentally everything's changing. I'm coming more and more to the result that someone who can critically think, someone who can problem solve, it's kind of like the job description has changed from what languages do you know, you know, what frameworks have you worked in, what things have you built previously, to can you quickly interpret something that just changed yesterday? Can you think quickly on your feet? Can you learn quickly? And can you utilize these tools to do all those things? And so I think what I say a lot of the time to people who like aren't in tech and they kind of ask me the same thing is that fundamentally, I don't believe our jobs have really changed. I think before, you know, the job description is to say the business or the stakeholders or the customer or someone has a problem, and it's our job to fix that. And before we would do that in, you know, by writing lines of code or, you know, researching by hand or whatever. And now we're still solving problems for the business, and now we just do it in a different way. And the business has a lot of problems, and I don't think they're going to go away. So, yeah, this is something that's on my mind a lot. I know this is more theoretical, philosophical, not necessarily technical, but it's something I think about a lot. So I don't know. It's already past 7, but yeah, if anyone wants to chat about it, it's something that it's on my mind a lot. So yeah, thanks.
I think feel free to stick around and chat. Otherwise, if you want, oh yeah, the raffle ticket. That's right. That's what I meant to do. All right. Did anyone still need a raffle ticket? Okay. I'm going to make Kyle pick our 2 winners for tonight. It's fine. Okay, 007. The last 3 numbers. Okay, we got Nick. One more, Kyle. .006. I'm guessing it's Maria because her name's on the back. So, all right.
Talked about how I don't know how raffle tickets work, and then I immediately lost my raffle ticket.
Yep. But yeah, thanks everyone for coming. If there's pizza left over, feel free to take some. Otherwise, stick around. I think it was August 26th is the next meeting, same time here. So yeah, look forward to it. Thanks.
Yeah.